Hello guys, my name is Deepak. I am studying in Sri Venkateswara College of Engineering. Today's our topic is Quicksort. Contents: Introduction to Quicksort. How does it works? Algorithm, time complexity, analysis of Quicksort, examples of Quicksort, advantages and disadvantages of Quicksort. Conclusion. Introduction to Quicksort. Quicksort is a widely used sorting algorithm known as efficiency and versatility. It follows the divide and conquer rule. Quicksort was developed by British computer scientist Tony Hoare in 1959 and was since become one of the most commonly implemented sorting algorithms. The best idea behind Quicksort is to select the pivot element from the array and partition the other elements into subarrays according to whether they are less than or greater than the pivot. This process is repeatedly recursively on the subarrays until the entire array is sorted. Next, how does it works? Pa- Partitionizing, choose a pivot, recursion, and combine. Partitionizing, rearrange the elements of the array so the elements are smaller than the pivot are placed before it. All the elements are greater than the pivot are placed after it. After this partitionizing step, the pivot is final sorted position. Choose a pivot. Select an element from the array to be used as a pivot, and this can be done in various ways. Picking first, last and middle element. Recursion. Recursively applied the above two steps to be the subarray of the left side of the pivot, containing the elements smaller than the pivot, and the subarray on the right side of the pivot, containing the elements greater than the pivot. Combine. Once the recursion reaches the base case of the subarrays with 0 or one more element, the smaller subarrays are combined to obtain the sorted array. Algorithm of quicksort. In the input, the subarray of the array are from 0 to n minus 1. Last element of the array means subarray, and output should be first and last rare and first case of the array sorted in the ascending order. Last element is less than the rare element, and the partition from E of and the algorithm of quicksort. Algorithm and partition. A assigns the value of p and L plus 1 assigns the value of I and R assigns the values of j. Repeat until 1 plus I is equal to I when A of j is greater than or p, and j minus 1 is equal to j until A of j is less than or equal to p. Swap A of I and swap A of j until A of j is greater than or equal to A of I is greater than or equal to j. Swap A of I and A of j. Swap A of I and A of j until return j. Next, complexity and analysis of quicksort. Time complexity of quicksort can be analyzed as follows. In the average case, the time complexity of quicksort is O naught, n log n, where n represents the number of elements to be sorted. The average case analysis assumes the pivot selection is random or uniformly distributed. The partitionizing process takes a linear time. Do not, as such, as each element is compared to the pivot exactly once. The worst case scenario, the quicksort can have a time complexity of O n square, and the worst case occurs when the pivot selection is consequently poor, leading to unbalanced partitions in each recursive step. In this worst case scenario, this is relatively rare in practice and can be avoided or minimized by using randomized pivot selection or other pivot selection strategies such as median of 3. It's worth nothing. The quicksort performance is highly dependent on the choice of pivot and the initial order of the elements. In the average case, the quicksort is efficient and widely used due to its average time complexity. However, in scenarios where the worst case behavior is a concern or when input is already partially sorted, other sorting algorithms like merge sort, heap sort may be preferred. Next, examples of quicksort. Here the elements are in unsorted array. Let for example 44, 33, 11, 55, 77, 90, 40, 60, 99, 22 and 88. Let 44 be the pivot element and scanning done from the right to left, comparing 44 element from the right side of the elements. If right side of the elements is smaller than the 44, then swap it. As 22 is smaller than 44, then swap the element. Just now elements become 22, 33, 11, 55, 77, 90, 44, 60 and 99, 44 and 88. Now comparing to the left side of the element, and the element must be greater than 44, then swap them. As 55 are greater than 44, then so swap it. For next term, recursively repeating the step 1 and 2 until we get two lists, one from left side from the pivot element and another from the right side of the pivot element. Now swap 77, 22, 33, 11, 40, 90, 77, 60, 90, 55 and 88. Now let the elements from the right side to left side are greater than the smaller than 44 respectively. Example, now we get the two sorted list 22, 11 and 40 and 44. 44 is the middle post element of the subset of 1 and subset of 2. Next, subset of 2 is maybe 90, 77, 66, 99, 55 and 88. Is same as follows this again. And these sublists are sorted under the same process as above done. These two sorted lists are side by side. Next, 22, 33, let's see the another example of quicksort. 22, 33, 11, 44, 40, 90 and 77. The first sorted list is 88, 77, 60, 65, 55, 90, 99 and sublist array of 3, 55 and 77, 60, 80, 90 and 99. Now at finally the sorted array of the quicksort is 11, 22, 33, 40, 44, 55, 60, 77, 88, 90 and 99. Next, advantages and disadvantages. Now first we go to the advantages. Efficiency, in placing sorting, cache efficiency, randomization, easy implementation. First, efficiency. Quicksort has excellent average case time complexity of Q0, making it one of the fastest sorting algorithm in practice. Quicksort the array in place, meaning it does not require any additional memory proportional to the size of the input. Quicksort has a good cache efficiency due to its localized and recursive patronizing processor, which can lead to the better performance in practice. Randomization. By choosing a random pivot or using a random pivot selection, the quicksort can achieve a average case time complexity. Time complexity even for more sorted or reversed input arrays. Easy implementation. Quicksort has a relatively simple and intuitive implementation, making it easy to understand and implement. Disadvantages. Worst case, unstable sorting, dependency on pivot selection, recursive overhead, not adaptive. First, worst case and time complexity. In worst case scenario, the pivot selection is consequently poor. The quicksort can have a time complexity of O0 in n square. This occurs when the array is already sorted or contains may duplicate elements. Unstable sorting. The sorting is an unstable sorting algorithm, meaning it does not guarantee the relative order of equal elements is preserved during the sorting elements. Dependency on pivot selection. The choice of the pivot element can significantly affect the performance of the quicksort. If the pivot is not well selected, it can lead to the poor patronizing, which implements the overall efficiency of the algorithm. The quicksort relies on recursion, which can lead to high memory consumption, potential stack overflow, issues of very large input arrays. Quicksort performance is adapted to partially sorted or relatively sorted arrays. It does not take advantage of exiting order in the data, unlike some other sorting algorithms like insertion sort and merge sort. Next. Conclusion. There might be a few drawbacks to quicksort, but it is the fastest sorting algorithm in an efficient algorithm that performs well in practice. It is useful even drawn simulation and operational research. In this video, we have learned what is quicksort, advantages and disadvantages of quicksort, and how to implement it. The quicksort is the best sort rather than merge sort and another sort, and it has more efficiency than other two sort algorithms. Next. Thank you.